All right, students, we're going to continue our discussion. I actually didn't intend for these to be mini lectures, but what happened was I accidentally cut off my previous recording. So we're going to just start off where we left off. So I'll call this mini lecture 2. We'll just continue that tradition. That was mini lecture 1. We looked at the power series expansion for sine x, and that's x minus x cubed over 3 factorial plus x to the 5th over 5 factorial minus x to the 7th over 7 factorial plus x to the 9th over 9 factorial, and so forth. Now, how do you remember this? You can remember that sine of 0 is 0, sine of 0 is 0. So if you plug in 0, I'll get sine 0 is equal to 0 minus 0 plus 0 minus 0 plus 0, and so forth. So that's how you remember it. And it is an odd function. It's an odd function. So remember that sine of negative x is equal to negative sine x. So if you plug in negative x here, if I do sine of negative x, I get negative x minus negative x cubed over 3 factorial plus negative x to the 5th over 5 factorial minus negative x to the 7th over 7 factorial, and so forth. So now I get negative x plus x cubed over 3 factorial plus, not plus, minus x to the 5th over 5 factorial plus x to the 7th over 7 factorial. So we see here that sine of negative x is equal to the negative of sine x. If we look at the power series expansion for sine of negative x, we see that it's the negative of the power series expansion for sine x. So now let's ask her this question over here. Well, let's just kind of take a look here and see that cosine of x is 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial plus x to the 8th over 8 factorial minus x to the 10th over x to the 10th over 10 factorial, and so forth. We see that cosine of 0 is equal to 1 minus 0 plus 0 minus 0 plus 0 minus 0, and so forth. That cosine of 0 is equal to 1, and cosine is an even function. Cosine is an even function. So that cosine of negative x, is equal to cosine of x. So we see that if we plug in cosine of negative x and replace x with negative x, I get equal to 1 minus negative x squared over 2 factorial plus negative x to the 4th over 4 factorial minus negative x to the 6th over 6 factorial, and so forth. So I see that in this case, if I look at the power series expansion, I confirm that cosine of negative x is equal to cosine of x. How about the power series expansion for e to the x? E to the x is equal to 1 plus x plus x squared over 2 factorial plus x cubed over 3 factorial plus x to the 4th over 5 factorial plus x to the, x to the 4th, that's not right, sorry. got ahead of myself here. That's x to the fourth over 4 factorial plus x to the fifth over 5 factorial, and so forth. So there's e to the x. Here sine x is equal to 1 minus x, not 1, x minus x cubed over 3 factorial plus x to the fifth over 5 factorial minus x to the seventh over 7 factorial plus x to the ninth over 9 factorial. Sorry. And so forth. Cosine of x is equal to 1 minus x squared over 2 factorial plus x to the fourth over 4 factorial minus x to the sixth over 6 factorial plus x to the eighth over 8 over 8 over 8 factorial, and so forth. So these three are really should be memorized, So you can remember that sine 0 is equal to 0, cosine of 0 is equal to 1, and e to the 0 is equal to 1. You can see if you plug in 0 for x, if you see 0 for x, you can get e is 1. So you see here e to the 0 is equal to 1. Sine of 0 is equal to 0. And cosine of 0 is equal to 1. Now, how did I come up with all this? This is really from the Taylor series expansion, and that states that f of x is equal to f of a plus f prime of a over 1 factorial x minus a to the first power plus f double prime of a, that's the second derivative, over 2 factorial x minus a square plus f triple prime of a over 3 factorial x minus a to the third power, and so forth. This f of a can be thought of as, the 0th derivative, evaluated at a over 0 factorial. You can kind of think of it that way. 0 factorial is equal to 1. 0 factorial is equal to 1. So this is equal to 1 here. And this top part, this numerator, is just simply f of a. The 0th derivative would be the function itself. Now, we call this a Taylor series. We call this a Taylor series centered at a. But if you set a is equal to 0, we have a special case of the Taylor series. Special case, and we call this the Maclaurin series, or Maclaurin expansion. Oops. Okay, let's take a look at this sine function. Let's take a look at the expansion of the sine function. We have sine x is equal to x minus x cubed over 3 factorial plus x to the fifth over 5 factorial, and so forth. Let's suppose I'm going to approximate sine x by just the first term alone. I'm going to approximate sine is approximately equal to x. How accurate is that? How accurate is this approximation? For instance, so now I remember, because this is an alternating series, remember this is a alternating series here. let's suppose I want to approximate sine of 0.1 by 0.1. How accurate is that? How accurate is that? Well, I'm going to remember that in an alternating series, the error is determined by the next term. So the error for an approximation, I have one term. I'm going to look at the first term here. First non-zero term. Okay. The first non-zero term approximates sine x to what accuracy? To within the, so this is like the error term. Error term. So if we're going to look at the approximating, if we're going to approximate sine x by x, I'm going to approximate sine 0.1 by 0.1. What's my error? My error is going to be 0.1 to the third over 3 factorial. 0.1 to the third over 3 factorial, which is going to be approximately equal to 0.0001666 and so forth. 6 is repeating. So there could be approximately, so I can say that the error, that sine of 0.1 approximated by 0.1 with error less than or equal to 0.000167. Well, let's take a look. What is sine of 0.1? Sine of 0.1 is equal to 0.09983334. Let me get my calculator here. So I'm going to do sine of 0.1 radians is going to be 0.90998334166, so forth. Okay. So I'm approximating this by 0.1. So I'm going to approximate. This is sine of 0.1. So what is the 0.1 minus 0.0998334166? So this represents the exact value. That's if you continued on the decimal approximation. Exact value of sine 0.1. If I take the difference, that difference is going to be equal to 0.000166583353 and so forth. So you see over here, I approximated sine 0.1. I approximate sine 0.1 by 0.1. I approximate sine 0.1 by 0.1. The actual value is this 0.099834166. If I take the difference between my approximation and the actual value, I come up with that difference being 0.00166583353 and so forth. Well, I know that the error was going to be within 0.000167. And so indeed here, this over here, this difference here is approximately, so the difference is 0.000166, and that's within 0.000167. Realizing that in an alternating series, the error from approximating the value of the function by the, in this case, the first term of the series, the error would be this error here would be the error would be given by the next non-zero term. So in this case, I find that if I have small values of the variable, I can approximate So note a sine x can be well approximated by x for small values of x. Note x x is measured in radians, not degrees. So I'm using the radian measure. So sine x can be well approximated by x for small values of x. So that finishes our second mini lesson. So we see that and we remember some kind of important things over here. The general formula for a Taylor series expansion given here. So this is the general Taylor series expansion. F of x is equal to f of a plus f prime of a divided by 1 factorial times x minus a to the first, plus f double prime of a over 2 factorial times x minus a squared, plus f triple prime of a, meaning third derivative, evaluate a over 3 factorial x minus a cubed and so forth. So this is the Taylor expansion of f at a. So this is the Taylor expansion of f at a. And so when a is set equal to 0, I get what's called a Maclaurin series, and these are very, very common and well-known Maclaurin series. For e to the x, it's 1 plus x squared over 2 factorial plus x cubed over 3 factorial and so forth. Sine of x is equal to x minus x cubed over 3 factorial plus x to the 5th over 5 factorial minus x to the 7th over 7 factorial and so forth. Cosine of x is 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial and so forth. And I could kind of remember how to start them off by remembering that e to the 0 is 1, sine of 0 is 0, and cosine of 0 is 1. So that ends our mini lecture number 2, and then we're going to come back again and do more of the Taylor expansions, and we're going to look at the remainder terms. Thank you.